Example 2. The enolization of beta keto esters is maximum in water, chloroform, acetic acid or CS2, carbon disulfide. Let's write the structure of beta keto ester. First, let's write an ester formula, C double bond O, and then we have an oxygen and then followed by an alkyl or an aryl group. On this side, we have a carbon chain. So, in case of beta keto ester, this carbon here attached to functional group is the alpha carbon. The next carbon is the beta carbon. This beta carbon has a keto group, a carbonyl group. Let's take one such example, or in general we can write here as R. Filling in the valency for this carbon, CH2. So, this is a general way how to represent a beta keto ester. Now, if this compound enolizes, then we will be having this hydrogen moving to one of these hydrogens, moving to one of these oxygen connecting here, and this pi bond forming a pi bond here, shifting here. So, let's write that compound R, C, single bond O, and now we have a H here. Here we have a pi bond, C, only one H is here, and then C double bond O, OR. In this type of a compound, we have hydrogen attached to an electronegative atom. Next to it, we have another electronegative atom. So, there is a force of attraction present between these two, which is what we call as a hydrogen bond. This hydrogen bond stabilizes this enol form, and hence enol content is more. The problem is, if there is a solvent which is protic, if it contains hydrogen attached to electronegative atom, like say for example water, H2O, then this hydrogen starts to form, this oxygen forms a bond with this hydrogen, or this hydrogen bonds to this oxygen. Therefore, the hydrogen bond between these two functional groups, rather than that happening, the hydrogen bonding is occurring with the solvent, because of which enol form is not that stable. Hence, we say that an enol form is obtained in more quantity or is more stable if the solvent is non-polar. In all these examples, the only non-polar solvent which is present is CS2, carbon disulfide. Carbon disulfide looks like this. It has dipole moment 0. So, therefore, this is a non-polar solvent. It does not hydrogen bond at all with your enol, and hence the enol is stabilized in this manner by hydrogen bonding with its own carbonyl group, and therefore it is stable and the quantity obtained, the enolization observed is maximum. Answer here therefore is option D. Its minimum in A, water, its maximum in D,